ESPN is proud to present this commercial-free telecast of SportsFigures, supporting education for America's youth.
The following program is part of Cable in the Classroom, a free service of the cable communications industry and your local cable company.
Hi, I'm Reese Davis, and welcome to ESPN SportsFigures. This is the only show where you'll hear Cincinnati Reds All-Star Barry Larkin say this:
C squared equals A squared plus B squared.
ESPN SportsFigures is where sports and science go one-on-one. So let's join Marissa Copeland and Barry Larkin at Disney's Wide World of Sports in Orlando.
And here's the pitch. Larkin swings and smacks the ball out over there. Larkin's running now, kind of to his right. Wait. Now he's turning to his left. Yes, he's definitely going that way. Oh, this is great. The other guy's throwing the ball to the other guy. Larkin's going the other way. And the other guy's running toward Larkin now, and the other guy's throwing the ball. Larkin tries to go back. Oh, but he's tagged out. Wow. Now that's baseball, folks.
What's baseball? What just happened?
SportsFigures, put your brain in the game.
If you're listening to a baseball game on the radio, it's a lot easier to understand it if the announcer says,
The ball is hit hard down the left field line. Larkin rounds first, heading for second. Agbayani has the ball. Larkin heading for third. There's the throw. Larkin doubles back to second, but Ventura makes the throw to second. Larkin turns for third, but the throw beats him, and he's tagged out.
see, that's because the announcer gave us the coordinates of the play. Or you might have heard them described as 6-4-3 double play or a fly 9-4 out. These numbers are also coordinates, numbers that tell us the location of the ball at different times. That's what coordinates do. They tell us location. To help us out today, we've got Barry Larkin from the Cincinnati Reds. He's an 11-time National League All-Star and a 9-time Silver Slugger team member and a 3-time Gold Glove Award winner. So he knows his way around a baseball field. Hey, Barry! So Barry, what's a 6-4-3 double play?
That's a ground ball to the shortstop who throws to the second baseman, who touches second, he throws it to first.
So all the players are assigned numbers, and they're not the numbers on their jerseys, right?
Right.
And what's the bat boy?
No number for the bat boy, just BB. So when the ball is put into play, the numbers tell the path of who handles the ball. The shortstop 6 fields the ball, who throws to the second baseman 4, who throws to the first baseman 3. A 6-4-3 double play.
Oh, so even if you're out getting a hot dog, you know exactly what's going on. The numbers are part of a system, and the terms of the system are defined. This coordinate system works great for baseball, but it's pretty much useless for other sports. In fact, even for baseball, it's not that exact. I mean, we know the shortstop got the ball, but I could have been here, or here, or here. We need something better. We need a way to describe the point exactly.
Your seat's right there.
Right where?
Right there.
My seat is up there. To get there, I have to go over 5 seats and up 4 rows. Over 5 and up 4. To make a graph of this, we just need an x-axis and a y-axis. That just means we draw 2 lines, the axes, at right angles to make a grid like this. To get to my seat, I go 1, 2, 3, 4, 5 on the x-axis and up 4 on the y-axis. So that means x is 5 and y is 4. That makes the coordinates of my seat 5, 4, x, y. This system of graphing things where the axes are at right angles is called the Cartesian Coordinate system. It's named for this French guy from the 1600s, René Descartes. Descartes, Cartesian, get it?
Oui, oui.
X and Y axes graph things in 2 dimensions. X is one dimension and Y is the other. We can also call our coordinates ordered pairs. Hey, Peanuts! Now you can make a graph like this out of any 2-dimensional situation. And the units of measurement can be whatever you want. In this case, we use seats and rows, but you know, it could be inches or feet or even peanuts. We can also put our graph anywhere we like on the problem. A full Cartesian coordinate graph looks like this, centered on the problem and making 4 quadrants. They're numbered like this. The x and the y-axis are numbered in whatever unit of measurement we're using. We use positive and negative numbers. And where the x and the y meet, that's our 0 point. We start counting from there, so that's called the origin. See, you could lay a Cartesian graph over a baseball field and get a really accurate description of where the ball traveled. If we used feet as our units of measurement and put the origin at home plate, the x-axis along the first baseline, and the y-axis down the third baseline, we'd get 0, 0 where the batter hits the ball. The entire field is in the first quadrant. Larkin fields it at 45-95 and throws it to Reese at 90-90. A quick spin and a throw to Casey at 90-0 for a double play.
It gives us a totally clear picture of where each player was. We actually use Cartesian graphs in daily life all the time.
A map is an example of a Cartesian graph. When you look up a road on a map's index, it gives you a coordinate. Like Jackie Robinson Parkway is E6. That's a coordinate, an ordered pair. See how there's letters going down this axis and numbers going across this one? Well, you go up one axis to E and across the other axis to 6, and there it is, Jackie Robinson Parkway. So where else in daily life do we see Cartesian graphs?
A graph like this in a newspaper is our Cartesian graph too.
But it doesn't really look like what we've been talking about.
It's still an x and y axis. You see, there's a unit of measurement that runs along the x-axis and a unit of measurement that runs along the y-axis.
A graph like that makes a picture of numbers so we can compare them really easily.
Oh, I see. So you can have different units of measurement running down each axis.
Yeah, like if you want to do Barry's batting average year after year. One axis would be the year and the other his batting average. A Cartesian map can graph location.
Or create a graphic picture of numbers.
Ah, graphic graph. I get it. Oh, yes! Oh, go! Using coordinates, we can figure out where you are at any moment on the field.
Okay, cool. I'm with you.
Here's something else that's cool about the Cartesian grid. We can use it to figure out distances. Like, let's say you're fielding a ball back here, and there's a runner heading towards home. Do you know exactly how far your throw would have to be?
Nope. But we can figure it out using the coordinate system.
Using our same graph, we can easily determine your position on the field.
Right. I'm 47 feet down the x-axis and 120 feet down the y-axis.
Right, and if we draw those lines in, we get
a right angle.
Right. Now you throw the ball to home plate.
Okay, so if we draw on the path of the ball, we get a triangle.
And what kind of triangle?
A right triangle, because one of the angles is 90 degrees.
So the path of the ball from here to home plate forms the third leg of our right triangle. And thanks to our Cartesian graph, we know that the first leg is 47 feet and the other leg is 120 feet.
Right, the path of the ball is the hypotenuse of the triangle, the side opposite the right angle.
So we can use our Pythagorean theorem to find the length of the side. And the Pythagorean theorem is?
C squared equals A squared plus B squared.
To solve for C, the distance of the throw home, all we have to do is plug the numbers in. 47 squared is 2,209 plus 120 squared, 14,400. So we get C squared equals 16,609. We want to solve for C, so we get rid of C squared by finding the square root of our result. Okay, Barry, you may have a golden glove and be an all-star, but can you figure out the square root of 16,609?
Yeah, that's really easy. All you gotta do is punch it into the calculator here. There it is, 128.87.
Okay, so we'll just round that off to 129 feet from here to home plate.
But what if the play was to throw to first base instead of home? How far would the throw have to be then?
Well, using a Cartesian graph, you can figure out distance from any point on the field to any other point.
So how do we do that?
When Barry throws the ball to first, the path of the ball makes a new triangle with a new hypotenuse.
For first base, it looks a little more complicated, but it's still easy. To figure out the distance between 2 points on our Cartesian graph, we still use the Pythagorean theorem. But our A and B legs have to be the difference between the 2 points on the grid. So we just subtract our coordinates. X2 and Y2 are where the ball ended up, first base. And X1 and Y1 are where it started from. We already know where Barry was. His position on the x-axis was 47 feet, and his position on the y-axis was 120 feet.
The ball ended up right here, first base. So all we need to do is find our coordinates, x2, y2. Pretty simple. Now, the x-axis is our baseline, and we know that first base is 90 feet from home plate. Now, we haven't traveled any distance on our y-axis, so the coordinates for first base are x2 equals 90, y2 equals 0. So we just plug our numbers in, and a little quick subtraction gives us c squared equals 43 squared plus negative 120 squared. Solving it with the Pythagorean theorem, we get c equals the square root of 1,849 plus 14,400. That means c equals the square root of 16,249.
And Barry, the square root of 16,249 is?
127.47 feet, which will round off to 127 feet.
Bada bing, bada boom. 127 feet from here to first base. So far, we've only been talking about Cartesian graphs in 2 dimensions. X is one dimension and y is the other. We've only been tracking things on a flat plane like this. But baseball and the world doesn't exist in only 2 dimensions. We live in a 3-dimensional world. With our x and y axes, we've been able to locate the ball from side to side, but from this view, it'd be pretty hard to tell if the pitch is high or low. For that, we can add a third axis to our Cartesian graph. It's called the z-axis, and it lets us analyze things in 3 dimensions. The z-axis works just like our x and y axes. It just adds a third coordinate to our system. It's like if x is east-west and y is north-south, z is up-down. On our 2-dimensional graph, we know the location of this ball. It's coming right over second base, and we know the coordinates of second base are 90, 90. But we have no idea whether it's going to be an easy snag or if it's going right over me for a single. Using our z-axis, we can add a third coordinate. So now x is 90, y is 90, and z is 10 feet. 90, 90, 10. So now we have a true picture of the exact location of this ball. And we know there's no way I'm ever going to catch it. Barry, you volunteered your time with us today. How come?
Volunteer? What do you mean? I'm not getting paid for this?
Oh, you didn't get the donuts?
No, I think it's pretty cool to help kids learn.
Okay, guys, so what did we learn?
That you can use a graph to map the exact location of things on a coordinate system.
That's called a Cartesian coordinate system.
And it can be used in 2 dimensions with an x and y axes, or in 3 dimensions by adding a z-axis.
And not only can you find the exact position of things, but you can also figure out the distances between any of the points.
Find the distances using the Pythagorean theorem.
Okay, these guys know what they're talking about. Oh, heads up! I got it!
Well, that's it. We'd like to thank Barry Larkin and our students, Colby, Ben, Jordan, and Larry. We'd also like to thank Disney's Wide World of Sports Complex located at the Walt Disney World Resort in Orlando, Florida, with over 200 acres of athletic facilities. And it's also the spring training home of the Atlanta Braves. For helping us out here today on ESPN SportsFigures, Cartesian Baseball.
I'm Reese Davis back here in the ESPN studios. Thanks for joining us for this edition of SportsFigures. Put your brain in the game. We'll be back next week with more ESPN SportsFigures.
We'd like to thank all the sports figures who participated in today's show free of charge. ESPN SportsFigures is presented commercial-free for educators to take and use in the classroom. For a free teacher's curriculum, to order the SportsFigures series, or if you have questions or comments, visit our website, sportsfigures.espn.com. You can also call 860-766-2000 or drop us a note at ESPN Plaza, Bristol, Connecticut.
This has been a presentation of ESPN, the worldwide leader in sports. For more, log on to ESPN.com. SportsFigures, put your brain in the game.
The preceding program is part of Cable in the Classroom, a free service of the cable communications industry and your local cable company.
ESPN is proud to present this commercial-free telecast of SportsFigures, supporting education for America's youth.